LangGraph's asynchronous PostgreSQL storage abstraction, AsyncPostgresStore, implements connection pooling as a core performance mechanism, allowing concurrent database operations while efficiently managing resource allocation through configurable minimum and maximum pool sizes. This pattern leverages PostgreSQL's native connection capabilities while adding async context management for clean resource lifecycle handling. We'll examine how the store initializes from a connection string, configures pool boundaries with min size and max size parameters, and executes mandatory schema setup via the setup method, all within an async context manager that ensures proper connection cleanup. The code demonstrates both the instantiation pattern and the one-time migration requirement before operational use. From LangGraph, store. Postgres import AsyncPostgresStore pool config. Constring equals PostgreSQL //user pass at localhost 5432/db name. Async with AsyncPostgresStore from constring. Constring. Pool config equals pool config. Min size equals 5. Max size equals 20. As store. Await store setup hash run migrations. Done once. Hash use store with connection pooling. This code demonstrates connection pooling configuration for AsyncPostgresStore, a critical performance optimization for database operations. The pattern uses pool config to define minimum and maximum connection sizes, here set to 5 and 20 respectively. This approach balances resource utilization and responsiveness, preventing both connection starvation during peak loads and excessive resource consumption during idle periods. The implementation follows the object pool pattern, where connections are reused rather than created, destroyed per operation. The fromConstring method initializes the store with these pooling parameters, while the setup method handles schema initialization. This design is particularly valuable in async contexts where connection overhead is more pronounced, though it requires careful tuning of pool sizes based on expected workload. The trade-off here is between memory usage and performance. A larger pool reduces wait times but consumes more resources, while a smaller pool may cause contention. The chosen values suggest a system expecting moderate concurrent operations with headroom for bursts. This pattern is essential for production systems, but requires monitoring to adjust pool sizes based on actual usage patterns. Let's break it down. From LangGraph, store. Postgres import AsyncPostgresStore pool config. Imports AsyncPostgresStore and pool config from the LangGraph PostgreSStore module, providing asynchronous PostgreSQL storage capabilities and connection pooling configuration. Constring equals PostgreSQL //user pass at localhost 5432/db name. Assigns a PostgreSQL connection string to the variable constring using the standard URI format, specifying the database type, authentication credentials username, user, and password pass, server location localhost on port 5432, and target database name, DB name. This string follows the lib connection URI standard and would typically be used to establish a connection to a PostgreSQL database. Async with AsyncPostgresStore from constring. Initiates an asynchronous context manager for creating an AsyncPostgresStore instance using a connection string. The fromConstring class method is called to instantiate the store, and the async with statement ensures proper resource management for the asynchronous database connection. Pool config equals pool config. Min size equals 5. Creates a pool config instance with a minimum pool size of 5, configuring the connection pool to maintain at least 5 active connections. Max size equals 20. sets a maximum size limit of 20 for a collection or buffer, likely constraining how many items can be stored or processed. The exact context isn't visible, but this parameter would enforce a hard cap on capacity.
Await store setup #run migrations. Done once.
Asynchronously calls the setup method on the store object to initialize the database by creating required tables and running migrations. This operation must be executed once before using the store and is performed asynchronously. The AsyncPostgresStore implementation demonstrates a production-ready pattern for managing PostgreSQL connections in async environments, where connection pooling becomes essential for balancing performance and resource efficiency. By configuring min size and max size through pool config, the system maintains a baseline of ready connections while allowing controlled scaling during peak loads, here set to 5 and 20, respectively. This object pool pattern ensures connections are reused rather than recreated per operation, which is particularly valuable in async contexts where connection overhead is more pronounced. The Async with Context Manager handles resource lifecycle, while the mandatory setup call ensures schema initialization before operational use. Together, these components form a robust foundation for database operations, though the pool size trade-offs, memory versus responsiveness, require tuning based on actual workload patterns. The design reflects a system expecting moderate concurrency with burst capacity, a common requirement in production async applications.
The pool hums with idle connections, while migrations draw tables that vanish at dawn.